A very good morning, friends. Today we'll continue 3D line and plane. So this is lecture number 23 on line. So let us begin. There are two theorems in line. First theorem is what? If a line passes through point capital A bar, then prove that and parallel to vector V bar. It is not mentioned here. Passing through point A bar parallel to vector V bar is equal to AI plus Bj plus Ck bar. Then prove that equation of line in vector form is R bar is equal to A bar plus lambda V bar. Hence find equation of line in Cartesian form. This is line passing through point A bar, and it is parallel to vector V bar. As all of you know, line is locus. So to find equation of locus, we take one point. In two-dimensional geometry, we used to take Pxy. Now in three-dimensional geometry, we'll take capital R bar. Let R bar be any point on line which passes through point capital A bar and parallel to vector V bar. Therefore, AR bar parallel V bar. All of you know that when two vectors are parallel, they can be expressed as scalar multiples of each other. Therefore, there exists scalar lambda such that AR bar is what? Lambda times V bar. AR bar is what? R bar minus A bar is equal to lambda V bar. So R bar is what? A bar plus lambda V bar. Is equation of line in vector form. to write equation of line in Cartesian form. Let R bar corresponds to x, y, z, be any point on line which passes through point A bar corresponds to x1, y1, z1 and parallel to vector v bar is equal to ai plus bj since R bar is what? A bar plus lambda v bar. So R bar minus A bar is what? Lambda v bar. Replace the value of R bar. R bar is what? Xi plus yj plus zk minus x1i plus y1j lambda into v bar is what? ai plus bj plus ck. Now when you subtract, you will get x minus x1 I bar plus y minus y1 j bar plus z minus z1 is equal to lambda a I bar plus lambda b j bar plus lambda c k bar. On equating, we get left hand side component of I bar is what? X minus x1 is equal to lambda a y minus y1 is equal to lambda b and z minus z1 lambda c. Sorry, this is a, not a bar. Therefore, x minus x1 upon a is lambda, which is also same as y minus y1 upon b is also lambda, is equal to z minus z1 upon c. Is equation of line in Cartesian form. Second theorem is what? If a line passes through points A bar and B bar, then prove that equation of line in vector form is R bar is equal to A bar plus alpha times B bar minus A bar. Also write equation of line in Cartesian form. This is line which passes through point A bar and B bar. As you know, line is a locus. To find equation of locus, we take one point on it. Be any point on required line. Let capital R bar be any point on a required line which passes through points A bar and B bar. Therefore, points A, B, R are collinear points. Therefore, AR bar and AB bar will be collinear vectors. Therefore, there exists a scalar alpha such that AR bar is what? Alpha times AB bar. So R bar minus A bar is what? Alpha times B bar minus A bar. So R bar is what? A bar plus is equation of line in vector form. To write equation of line in Cartesian form. Let R bar corresponds to x, y, z. Be any point on required line which passes through points capital A bar corresponds to x1, y1, z1, and capital B corresponds to since R bar is what? So R bar minus A bar is what? Lambda B bar minus A bar. R bar is what? Xi plus Yj plus Zk minus x1i plus y1j is equal to lambda into x2i plus y2j. This is B bar minus x1i plus y1j plus z1k. Therefore, x minus x1 I bar plus y minus y1 plus z minus z1 is equal to lambda x2 minus x1 I bar plus lambda plus lambda. Sorry, I have taken scalar alpha. Alpha y2 minus y1 alpha k bar. On equating we get x minus x1 is equal to alpha and y minus y1 is equal to alpha into z minus z1 is equal to alpha into so x minus x1 upon is alpha, which is same as y minus y1 upon z minus z1 upon is equation of line in equation of line passing through A bar of line passing through A bar corresponds to 1, 2, 3. And parallel to vector v bar is equal to 3i plus 2j minus 2k bar. In vector form, is given as r bar is what? A bar plus lambda v bar. R bar is what? A bar is what? I plus 2j plus 3k. Plus lambda times v bar is what? 3i plus 2j minus 2k. This is in vector form. In Cartesian form, equation of line in Cartesian form is x minus x1 upon a z minus z1 upon c. X minus x1 y1 z1 is what? Point through which line passes 1 2 3. So x minus 1 upon a is what? 3. Y minus 2 upon b is what? 2. Z minus z1 is what? 3 upon c is minus 2. This is in Cartesian form. See question number 2. Equation of line passing through points A bar corresponds to 3, 4, minus 7 and B bar corresponds to 1, minus 1, 6. In vector form, is R bar is what? A bar plus lambda B bar minus A bar. R bar is equal to A bar is what? 3i plus 4j minus 7k plus lambda into B bar is what? I minus j plus 6k minus 3i plus 4j minus 7k. So R bar is what? 3i plus 4j minus 7k plus lambda into I minus 3i is what? Minus 2i minus j minus 4j is what? Minus 5j plus 13k. In Cartesian form, equation of line in Cartesian form is x minus x1 upon x2 minus x1 is equal to y minus y1 upon z minus z1 upon z2 minus z1. x1 y1 z1 is what? 3 4 minus 7 upon 1 minus 3 minus 1 minus 4 and 6 minus of minus 7, that is x minus 3 upon minus 2, y minus 4 upon minus 5, (13). If the Cartesian equation of line is this, then we have to find vector equation of line. Equation of line in Cartesian form is x minus 1 upon 2, y plus 2 upon 3, z minus 5 upon. This implies line passes through point 1 minus 2 5. A A 1 minus 2 5 and parallel to vector
अरे आप ये यार करने से होगा
नहीं
इन पे क्लिक करो ठीक है मैं आओ
थिक पेन पे ही हो
इनमें ड्रॉ है पर ये स्क्वायर में
ये
ऊपर स्क्वायर वाला ठीक है
थिक पेन ही किया है ना, ये क्या है?
ये है ना
अच्छा हाँ,
क्या ये ठीक है ये करोगे
and parallel to vector v bar is equal to 2i plus 3j minus k. Therefore, equation of line in vector form is r bar is what? A bar plus lambda v bar. A bar is what? I plus 2j minus 2j minus 2j bar plus phi k bar plus lambda into 2i plus 3j minus k is equation of line in vector form.